Hi, I'm going to show you how to use Kubetorch to launch a VeRL or VeRL training to do reinforcement learning. VeRL is a library that was released by ByteDance and abstracts a lot of the RL process by using Ray under the hood. It also integrates with systems like VLLM or SGLang for inference, and it offers a number of configurations that you can find in their GitHub repo. As far as this demo goes, Kubetorch doesn't have a lot to do with the underlying program. In fact, we launch VeRL almost as is, and we borrow a lot of their sample code. Instead, what we want to show here is how easy it is to form a Ray cluster and dispatch work to it with Kubetorch. So at the beginning, I define a simple run grpo function. This is my training entry point, and for the sake of this demo, I'm actually going to use a config that I pass in as an argument. This config is going to eventually make its way to run PPO, which is actually VeRL's entry point into training. And along the way, I'm actually going to download the data and download the model as well. This run grpo function as a whole is going to run on a remote Ray cluster while I run the program locally from my machine to bring up that Ray cluster and send the work there. You can see that the download data and download models are pretty straightforward, regular functions. And the config is borrowed from their entry point, but I just put it into a YAML file instead. We're going to use 1.5 billion instruct, and I'm running over some A100, which are a nice price to performance for a startup like us. So actually, to run this program, we first need to define an image, which includes the VeRL base image. We're using the one that uses VLLM. We're layering on some additional installs on top of that, including VeRL itself. And then we're setting the environment variables for 1db key. And now VeRL is going to be able to use that and log my results to 1db. I define the compute that I want this to run on. I can run this on GPUs that I grab from the config. I can set other fields such as CPU and memory, though that's not super necessary here. I pass in the image. And then I also allow for the serialization of my config from my local machine into that remote service that I'm going to bring up. And most importantly, I'm going to start this program with Ray. With Kubetorch, adopting Ray is extremely simple, much like you would say distribute PyTorch for PyTorch distributed, or no distribution method at all for embarrassing parallelism. If I just simply say Ray here and get the number of nodes from the config, I'm going to form up a Ray cluster, which here is going to be 4 nodes, and I'm going to send my run grpo training to that Ray cluster, and I can call it locally as is. You can see here that it's been running for a while, it's been stepping through various steps, and it's progressing normally. And I simply had called it from my local machine with my config, and then it gets dispatched to that Ray cluster I formed. It took a few seconds for the training to get started, so that's why I started with the training already running. But to see what it looks like from scratch, we can start by tearing down my existing service and starting one back up again. Now that my service has gone down, I can start it back up again simply by calling python VeRL train.py. And you can see that I'm bringing up a Ray cluster. My nodes are already warm, so I can assign these pods quickly. And we have the container image cached as well on the machine. And so now what it's going to do is run the setup for my pip installs in addition to that base image. And we make it very simple here for you to lightly modify the base image without having to rebuild the entire Docker container again. And you can see that if I open up a new terminal, you can see that my Ray head node and my workers are coming up. You can see that the data set has generated. You can see the data is pre-processing and the training is now going to start. So overall, this process was fairly painless to use VeRL. We do see some teams progress very quickly from VeRL to more custom frameworks, such as we show in our other example for using just regular classes and functions without a framework to do RL. Ray imposes some rigidity, VeRL imposes some rigidity, and running at scale RL is probably best done with custom implementations of the inference, the evaluation, the reward, and the training classes, but it's a simple way to get started, and adopting Kubetorch means that it's almost no cost at all for you to try a Ray program or launching a VeRL program.